Hi, this is Ms. Wiles, and in this video we'll have 4 more examples of 4 different ways to solve and possibly factor or check for factors for a quadratic equation. In this first example, you see 21p squared minus 18p. Now, the first thing that you should do is check for any greatest common factors. And we look at the 21 and the 18 and what those numbers have in common. The greatest number that those have in common with each other is 3, because 21 is 3 times 7 and 18 is 3 times 6. And then we can look at the 6 and 7 and we know that there's not anything that they have in common, and we know we're good. Now the p squared and the p, what they have in common is the p, because p squared is p times p and p is just p. What we have left when we factor out the 3p is 7p for the first term, because 3 times 7 is 21 and p times p is p squared. What we have in common when we factor out 3p from the second term is minus 6, because 3 times minus 6 is minus 8p, or 18, and p times nothing really is, or 1 is p. All of that still equals 0. For that to be true, either p would have to be equal to 0. When we see the 3p outside, that's where that 0 comes from. And or p would have to equal 6 over 7. The opposite of the minus 6 over the 7. These are my factors. Or this is the factor form. And these are my 2 solutions. Number 2. In number 2, we could check for common factors, and you really kind of should. You should just get into that habit. But in this case, even if we factored out the 3, this would still work the same way. So I'm going to leave that out for now, because we talked about just solving this using square roots. And we move that minus 15 or plus 15 to the other side of the equation, making this equation 3x squared equals negative 15. Then we divide both sides of the equation by 3, and we have x squared equals negative 5. Then we take the square root of both sides of the equation, and x equals plus or minus the square root of negative 5. We check to see if our radicand can be broken down. And 5 is just 5 times 1. Even if it was 6, it'd be 3 times 2. Unless there's a perfect factor that can be factored out, then that square root of 5 will remain just like it is. However, the negative sign under the radical tells me that there's going to be an I. And so my answer, or my 2 solutions, are x equals plus or minus, positive or negative, I square root of 5. This is the one that is not really factorable. The only thing that we could do, and we could say that it equals 3 times x squared plus 5. But even that doesn't really have to be done to find the solutions. So if you said on your quiz or something that this was not factorable, I would accept that at this stage of the game. Next. Oh, that's really, really big. So we're going to make that a little bit smaller. This is a trinomial with a leading coefficient of 1. So in this case, I'm going to be looking for 2 numbers that if I multiply them, I get a times c. Now, a and c are 1 and 22. So those 2 numbers, when I multiply them, I want them to equal 22. When I add them, I want them to equal 13. So I'm going to multiply, looking for 22, and when I add, I get 13. So I start checking. 22 times 1, everything's positive, so everything has to be positive. That's 23, it doesn't match. So I'm going to say times 2. 2 times 11. Well, 2 plus 11 is 13, so I found my 2 factors. In fact, with the leading one, I've actually found the numbers that are going to be in my factors. My factors are x plus 2 and x plus 11. Those are my factors, and my solutions are negative 2 and negative 11. These solutions can be found in the table of the calculator if you graph this in y equals. If you graph that equation there, you can look back in the table and you can see that when x is -2, y is 0, and when x is -11, y is 0. When you see that kind of thing in a table, this tells you that these x values are your solutions. Number 4. Number 4 is also pretty big, so I'm going to make it a little bit smaller here so we have some room to work. Over here. All right. In this one, we have a trinomial where a is not, the leading coefficient is not 1. A is 5 and c is -6. So I want two numbers that when I multiply them, still kind of the same method as number 3, but just not as easy. When I multiply them, I want it to be a times c, which is -30. When I add them, those two numbers, I want them to be 7, which is b. Now, 30 is negative, so I know there has to be a positive number and a negative number. 7 is positive, so I know that the positive number has to be bigger than the negative number. So it might be 30 times -1. But when I add those together, that's 29, so that doesn't work. So then I try 2. Since it's divisible by 2, then I would say 15 times -2. When I add those together, I get 13, and I still say no. So I continue to look, and this is also divisible by 3. So it could be 10 times -3. When I add those two together, I get 7, and I'm like, yes, I've got it. Now here, it's a little bit different because I have to decide what to do with this 10n and this -3n, because these numbers that I get here in this method tell me how to split up that 7n. So I'm going to have to come over here and I'm going to have to split this 7n up into those two different values. Now I'm going to put one of those values that I think works best with the 5n squared. I'm going to put it with that. So I look at the 10n and the 3n. So I'm going to group that 10n here with the 5n squared. Then I'm over here, there's a -6, and I look at the -3n, and I'm like, okay, that has some kind of relationship too, because I know that the 3 and the 6 have something in common, the 5 and the 2 have something in common, so I know I've got them placed well. I look at the 5n squared, kind of split that into two different things that I need to look at. The 5n squared and the 10n, they have, the 5 and the 10 have a 5 in common, and the n squared and the n have an n in common. And what I have left when I factor that out is n plus 2. Both of these are divisible by 5, like 5 is 5 times 1 and 10 is 5 times 2. That's where the 5 comes from. And n is n times n, or n squared is n times n, and then that n, and they have that one n in common. That's why I have this n left over here, and that's how everything works there. I look over at this other side, and I know that with this method, I want to have an n plus 2 in parentheses. And that's going to give me a big clue as to what needs to go here. And when I look at this -3n up here, when I look at that, I know that this needs to be -3, and then I can just check to see, is -3 times 2 equal to this -6? I'm like, yes, I've got it. So now I've got what I need to be able to put these factors together. Through the magical wonder of math, the n plus 2 stays together, and what I have outside of those parentheses, it gets grouped together inside parentheses also. These are my factors, and from those factors, I can find my solutions of 3/5 and -2. Can those solutions be found in the calculator? Yes, they can. But that was another video, and there are plenty of other videos out there about using the TI-84 Plus calculator to find solutions of quadratic equations. So if you need more help on anything, let me know if you're in Fayetteville, North Carolina. And if not, look it up on YouTube. Because YouTube knows and Google knows, as long as you use a trusted source and check your work. That's all I have to say about that, and have a great day.